Good morning, class. Our today's lesson would be based on decimal to binary conversion, and it is a continuation of our learning from yesterday, which we learnt about binary to decimal conversion. Binary number was given in the form of 0 and 1, and it was converted into decimal number in our previous video. Today we will learn to find the binary equivalent of a given decimal number. See, like 75 over here, I have written it down as 1001011. How I drive the conclusion that 75 is equal to this in binary and 142 is equal to 1000110. So let us understand. So clearly converting decimal to binary also have two methods. Okay, let me zoom in so that you can have a clear view. Over here the question is that this 57 to the base 10 is to be converted into a binary number. Now how I got that this is a decimal number? Because base written over here is 10. In our first method, what we do is first we write 2's in the power, okay, till 2 to the power 8, like 2 to the power 0 is 1, 2 to the power 1 is 2, and so on. In the second step it is a little tricky. Okay, now we'll do what? See this number 57, compare it with 256. 256 is greater, 128 again greater, 64 again greater. Now 32 is smaller than 57, so we are writing first number as 32. Now we need to find what more must be added to 57, so we got 25. So this 25 comes from calculation, that is 57 minus 32, which is equal to 25. Now we see that 25 is again not in the list. Okay, 25 is again not in the list of which 1, 2, 4, 8, 16, 32, 64, 128, 256. 32 is there, so we are leaving 32 as it is, but 25 is not there. So again find a number which is less than 25. So 32 is not less than 25, so again 16 is taken. So if we added 16, then 9 comes in the remainder. Okay, so again 16 is in the list, so 16 is to be ignored, and 9 is not in the list, so something has to be done for it. Okay, so 16 is greater than 9, so we move ahead. 8 is less than 9, so we have writing 8 and plus 1 in remainder. But 1 also belongs in the list, so there is no need to do further changes. So 32 plus 16 plus 8 plus 1. Okay, now clearly 32 into 1, 1 into 16, 1 into 8 and 1 into 1 will give you your binary number. 32 can be written as 2 to the power 5 from the table over here, so 1 into 2 to the power 5. 16 can be written as 2 to the power 4, so 1 into 2 to the power 4. Similarly 8 can be written as 2 to the power 3, so 1 into 2 to the power 8, and 1 is written as 2 to the power 0. Okay, so clearly we see 2 to the power 5, so 1 is placed over here. 2 to the power 4, again a 1 is placed over. 2 to the power 3, again a 1 is placed over here. Now last one comes with 2 to the power 0. So that means 2 to the power 1 and 2 to the power 2 are multiplied with 0 only. Getting? You see, let me zoom in more. 2 to the power 5, 4, 3 are multiplied with 1. And then in last 2 to the power 0 is 1 with 1. So that means the two gaps which were in between are multiplied with 0. So in the places of gap we would be writing 0, and remaining places we would be writing 1. See, if you find this method very difficult to approach, there is a short and simpler method also, which is known as division method. Division method is very common, and I would recommend you to use division method during your exams also, because division method is simpler and more accurate. Now what we have to do is take the first number or the given number in the question 57, divide it by 2, and when we divide 57 by 2, remainder comes out to be 1. Okay, the quotient is 28, that is quotient of 57 divided by 2, that is quotient comes over here, and remainder is written in bracket over here. Now again divide 28 with 2, because 28 is an even number, so remainder would be 0. 14 2s are 28, so quotient comes out over here, remainder is written over here. Again 2 7s are 14, 0 over here, 2 3s are 6, remainder 1, 2 1s are 2, remainder 1, and then we have written all the remainders. we get to the last place of division, okay, where your dividend becomes lesser than the divisor, okay. Now when we write these remainder, we would not write in the order from top to down, but we would be writing in the order from down to top. See, the number is not written as 1001111, but it is written as 111001. So we are starting from bottom and we are reaching towards top. It is also indicated in the arrow. See, the last remainder is written first, the second last remainder is written in the second, and the first remainder is written in the last. When you will compare both the answers are same. Over here also 111001, over here also 111001. So this is the remainder method or the division method, where you divide the given number, you write the remainder in the bracket and you write the quotient over here, and you carry on the process until your dividend becomes less than the divisor and every number is written in a format from bottom to top. Let us see one more example of the calculation. The given binary number is to you, and you have to